All right, so we've hit chapter 7 and 8. That was our first real introduction into a lot of reactions with alkyl halides and different nucleophiles and bases. Chapter 9, we're continuing to learn more reactions, but we're changing our focus from alkyl halides to these three functional groups. Hopefully you already know the names of two of these functional groups, and then the third one will be kind of a new addition. But this is an alcohol. Alcohols always have carbon to OH bonds. This is an ether, and our group is a carbon, so ethers have carbons on both sides. And then this guy here, it's an ether, but it's a very special type of ether. You'll see that there's that three-membered ring. The three-membered ring has a lot of strain that impacts the reactivity of that three-membered ring. This is called an epoxide, which is just a very specific type of ether. And the way that this chapter works is we start with alcohols. Pretty much, I'd say 80% or so of the chapter is fully devoted to alcohol reactivity. And then we kind of touch on different components of these two later on in the chapter. So just like alkyl halide reactions, the type of alcohol impacts the reactions that it will undergo to a large extent. So if you guys had to just look at these three alcohols and classify them as different things, what would be the terminology you would use to distinguish this one from that one from that one? All right, yeah, perfect. So this is a primary alcohol, so I'll write primary ROH. This is a secondary alcohol. Again, the carbon is connected to two carbons. That's a secondary carbon, so it's a secondary alcohol. And then that one on the right, it's a tertiary carbon right there, so that's a tertiary alcohol. So that being said, just like alkyl halides, the type of alcohol has enormous impacts. Let's say enormous impact on the reaction type. So we know that tertiary alkyl halides did different stuff than primary alkyl halides. The same thing is going to hold true for alcohols. And now the thing that we have to touch on every new functional group that we talk about in depth is how do we name that functional group and what's kind of the naming conventions for that system. So we did that with alkyl halides in chapter 7. Now we're talking a lot about alcohols. We're going to learn to name alcohols, ethers, and epoxides. All right, naming acyclic alcohols. So something pretty different happens once we have an alcohol functional group on a molecule. We had a lot of rules for, you would want the longest carbon chain. That still holds true. You want your substituents to have the lowest possible numbers. That breaks once we get to the alcohol functional group. Anytime there's an alcohol on a molecule, we number the molecule to give the alcohol the lowest possible number. The lowest possible number. So that means that with this molecule that's shown here, if we numbered left to right, the alcohol would have number 4. If we number right to left, the alcohol has number 3. So the right to left naming is the ideal naming in the IUPAC system because the alcohol functional group has the lowest number. And it always takes priority over any of the functional groups we've talked about before. So even if something like a bromide could be number 2, if we numbered left to right, that loses to the overall new rule of alcohols get the lowest possible number. So we want them to come up first on our carbon skeleton. So that's new. So I'm going to erase that top numbering to say that's not correct. And then what do? We still have the same system that we learned about previously. We have a prefix linked to a parent, linked to a suffix. And what do those three things mean? What do we put in the prefix? What do we put in the parent? What do we put in the suffix? Pause the video and think about that for a second if it's not immediately coming to your mind, because if you remember it on your own, it's going to help your recall better than me just telling you. You already did that. Great. So prefix tells us where the substituents are. Parent is just about how long the carbon chain is. So parent is the longest carbon chain, and then it gets whatever it gets based on how many carbons there are. There's 6 here, so that's the hex parent. Suffix tells us the functional group type. And previously we've all been just alkanes, haloalkanes, so halogens with alkanes were still just alkanes with prefixes that told us where the halogens were. That changes again when we have alcohols. The suffix for an alcohol is OL, which should make a lot of sense, alcohol. So hopefully that isn't too much of a stretch. But essentially the way we're going to name this is we're going to say where our substituents are. We only have one substituent on here. It's the bromo. So we have 5-bromo. And actually, this is a good time for you, again, to pause the video and try and name this yourself. So you've done that. You've already come back. You've named it. So 5-bromo. And then we are going to put the parent next. So 5-bromo hex. And then ane for, it's hexane for there is an alkane. There are no alkenes or alkynes. That's the AN stands for alkane. But instead of putting the E on the end for alkane, we put the OL on there. And we also indicate where the alcohol is. It's in the 3 position, so we would do 3-OL. So this molecule is 5-bromo, hexane, 3-ol. Are we done? If you just saw this name, would you be able to draw this specific molecule? No, we haven't talked about the stereochemistry, right? Correct. So we have to put in if something is R or S. So we have 2 different stereocenters here. This carbon 3, this would be priority 1. Priority 2 would be over here. Priority 3 would be over here. The 4th group is in the back. It's this hydrogen. So we have it lined up perfectly for us just to do our circle. 1 to 2, 2 to 3. That is counterclockwise, so that's S. So this would be 3S. And then we also have this stereocenter here. I'll do that one in black. But the bromo would be the 1st priority. This would be the 2nd priority. And this would be the 3rd priority. 1 to 2, 2 to 3. Goes that direction. That's clockwise. R. So 5R. 5-bromo, hexane, 3-ol. So that would be the full name of this alcohol. So that's acyclic alcohols. Great. All right. Well, what about cyclic alcohols? Cyclic alcohol. So same IUPAC nomenclature as normal, but again, the alcohol functional group remains the lowest possible number. So we could have it be 1, 2, 3, 4, 5. Or we could go the opposite direction. Which direction should we go? So pause the video. Think about if you like the counterclockwise numbering or the clockwise numbering. Oh, skipped 4 and 5. So you did that. You're back now. So the alcohol gets the number 1, and then it defaults back to the IUPAC naming system. So what do we want to go, clockwise or counterclockwise? IUPAC nomenclature never says clockwise or counterclockwise is best, so it shouldn't be based on that. What it is based on is the substituent naming. So essentially we have 3 and 4, or we have 3 and 4, so that doesn't change anything, right? 3 and 4 numbers for substituents is the same as 3 and 4. Well, what about the substituents that are on 3 and 4? This is a methyl, this is an ethyl. So ethyl comes before methyl in the alphabet, so we would want the ethyl to have the lower number. So the counterclockwise is the correct option this time. But again, it has nothing to do with it being counterclockwise or clockwise. It's just about giving the lower alphabet to the lower number. So this one, alcohol functional group remains the lowest possible number. What is the lowest possible number in a cyclic molecule? It's always 1, right? Because wherever the alcohol is, if it's here, if it's here, if it's here, wherever, it's always going to be number 1. So it's always 1. So no need to specify. We don't have to write 1-all because it's known that it has to be 1 since it's a cyclic alcohol. I have a phone call, so I'll be back in a second. All right, we're back. We've covered that's the right way to number it. Now, how do we put everything out? Well, we have 3-ethyl, 4-methyl, and then what does a cycloalkane get as part of the parent name? Cyclo. Cycloalkane, cyclo. So cyclo, and then it's 5, so that's not hexane, it's pentane. So pentanol. So we don't have to put the 1-all, we just put pentanol. Again, what are we missing? Great, stereochemistry. You guys are already really good at stereochemistry at this point, so I'm just going to write them in. This is S. Yep, S. This is S. And this is R. So we would put 1S, 3S, 4R, 3-ethyl, 4-methyl, cyclopentanol. That being said, you guys already know how to do it, but I want to give you a chance to watch me do it anyway. So if you're already feeling really good about the stereochemistry, feel free to fast forward or just end the video at this point. But I'm going to walk through the numbering and naming again. So for this first one, why is it S? This is position 1. This position is the same for both. This position is an ethyl versus a methyl, so that's why this carbon would be number 2, and then that carbon would be number 3. So that's 1 to 2 to 3, counterclockwise, so that's why it gets the S. What about this one? This is a carbon attached to 2 carbons, carbon attached to 1 carbon, and a carbon attached to no carbon. So carbon attached to 2 carbons wins number 1, this wins number 2, this wins number 3, 1, 2, 3. That's clockwise R. And then I'm going to redraw the molecule right here just because it's getting pretty marked up. Okay, so at this point, this carbon is attached to a carbon with just 1 carbon. This carbon has 1 carbon, so these 2 are technically tied, but this one has a carbon attached to 2 carbons, so that's why this one wins number 1. So that carbon ties that carbon, but this carbon beats that carbon because this carbon's all attached to only hydrogens, this one's attached to an oxygen and a carbon. So this would be number 2, this would be number 3, 1, 2, 3. That's counterclockwise, so that's why that one is S. So hopefully that helped anyone that is kind of foggy on the S versus R.